Officially starting. Alrighty, so I've started the recording and let me also share my screen and then we'll go from there. Alrighty. Hello, ladies and gentlemen. Today's class is going to be on gRPC, which might be something you've heard of, but if not, maybe you've heard of tRPC or generally RPC, remote procedure calls. Why do you need them? You usually don't need them. You have simple HTTP servers like we have built until now, and they are good enough until your startup reaches a scale. When your startup reaches a very big scale though, which means you have a bunch of requests, maybe 20,000 requests per second, is when these things come into the picture. Why do they come into the picture? Because they can significantly help reduce your infrastructure cost. They can make things a lot faster. By infrastructure cost, I mean both your EC2 machine cost and your bandwidth cost, because gRPC specifically compresses data a lot when it's transferring data from point A to point B. And that's usually the use case. In a company like Uber, where a friend of mine worked and told me, they made this transition, not exactly to gRPC. They made a transition to something called protobufs, which is something we'll learn about today. But that's the high level overview of today's class. We're going to understand what are RPCs. How do you do RPCs? Why do you need remote procedure calls? That's what RPC stands for. Then we will understand what is gRPC. Why was that introduced? And we'll understand what are protobufs. We'll be doing a simple implementation in Node.js. And that's pretty much it. If you've gone through the OpenAPI spec class, you can think of gRPC as something similar, providing you some benefits similar to OpenAPI, but it provides a bunch of extra things. When do you need them? You need them when your application, when your cloud bills are more than $50,000 a month on bandwidth plus EC2, which means you're getting Swiggy scale of requests is when this comes in handy. All right, GraphQL is a similarish technology that also comes into the picture at scale. But I'll take a pause here and let's get right into it. The slides, unfortunately, for some reason there's a bug on the website. I don't see them here if I search for gRPC. So there's a link. I'm going to paste the link in chat. Feel free to just go to the link and visit the website and follow the slides. Yeah, you won't find it. If you don't have the link, then okay, this is the link right here. Just go to projects.netextsteps.com/tracks/gRPC. Let's get right into it. Forget gRPC. First, what is a remote procedure call? This will become important even in the Web3 cohort because most blockchains expose their APIs as JSON RPC, which is another way to do remote procedure calls. RPC stands for remote procedure call. The name itself might give you a little bit of a hint. Until now, if there are multiple backends, let's say, or even a front end and a backend, until now, this is how we make them communicate with each other. Harkirat, you said we to communicate via pub subs, we communicate via Redis. Yes, we do that as well. But let's say you have to directly call the other side. You have to make the other backend do something and return a response. Then you might do something like this. Let's say you have 3 backends. One backend is in Rust, which exposes an HTTP server. One is in Node.js, also exposes a HTTP server. If you look at this is fairly simple express code over here. app.get/request response, return some data. The first backend, if it wants to talk to the second backend, it might do something like this. It will do a await axios.get. It will send a get request and then finally get back the response. This is how backends would communicate, or even a front end and a backend would communicate. But there are some problems in this. The easiest problem here is there are no types. The backend is returning you the data. The front end doesn't know what the type of the data is. It could be anything. If you actually write this code, you will see the type of data is any. If you check the type of rest.data, which we will very soon, you will see the type is any. You don't know what the type of data you got back from the backend. If you've heard of tRPC, maybe not. This is something we covered in cohort 1, but tRPC gets rid of this problem. So if you have a Node.js backend and a Node.js frontend and you need types on both the frontend and the backend, you can use tRPC. But in the real world, you will also have Rust backends. You also have Golang backends. There you cannot use tRPC. tRPC is just a full stack framework for Node.js or frontend in React or backend in Node.js. It is not a framework for Rust, which is why if you have a very big company which has Golang, Rust, Node.js, bunch of backends, usually the easiest thing you can do for them to communicate with each other is expose everything over HTTP, and then whatever service wants to call another service can just do an HTTP call, get back the response, and then go from there. This is good. There is no downsides in it. But at scale, it creates problems. Problem number 1, since you don't know the type of data, in your TypeScript code, you can't really catch a bunch of compilation errors. This data, you will have to go to their company or, go to the developer who has written this code, ask them, hey, what data does this return? And then, put that data here explicitly. You might say, Harkirat, OpenAPI spec solves this. Yes, that's one thing that OpenAPI spec solves. But let's say you don't have OpenAPI spec. Then, how will you figure out? You will have to read the code and understand, oh, acha, this is what it returns. And then, write your code over here. There is no automatic type that you get when you call this. Problem number 2, you as the developer need to know, Axios is a library that sends HTTP requests. You basically have to understand REST or HTTP generally. Wouldn't it be nice if you could just do a function call over here? Remote procedure calls. What does the name say? Remote procedure call, RPC, which means, wouldn't it be nice if I could just write await get to-dos? Let's say that's what this backend does. And then, under the hood, an Axios request goes out, you get back a response. Wouldn't it be nice if you could do a remote procedure call, which, since you're calling a function, it might be able to return you the types as well. But even if it doesn't return types, it's much cleaner to write as a developer rather than, figuring out, acha, this is the URL I have to hit, this is the route I have to hit, this is the parameters that I have to send. This is where RPC shines. RPC stands for remote procedure call. What if you could encapsulate all of this logic somewhere else? And the developer has to just write const res equal to await get to-dos, and it gets back all the to-dos in this res object. That is what RPCs are used for. gRPC specifically does one extra thing. Another problem here is they are most probably transferring JSON. When you ask something, you probably send body in as JSON. Whatever response you get back as JSON. JSON is very expensive when it comes to serializing it, when it comes to sending it over the wire, when it comes to deserializing it. JSON is one of the worst formats you can use for data exchange. Everyone uses it because they're very easy to write. But before JSON, there was something called XML that people used to use. Today, JSON is very popular. You use JSON, send it to the other side, and the side understands, good to go. But at scale, you will see significant, or you can get significant benefits if you compress the data. If you somehow zip the data while sending it, and then unzip it here, and vice versa, before it responds, it zips the data, makes it really small, compresses it, and returns it to the other side, then that can lead to significant, reduction in bandwidth costs and significant increase in the speed, which translates to, less CPU usage, which translates to you can have smaller CPUs or smaller machines in your cloud. That is why, or that is where gRPC comes into the picture. Number 1, it lets you do remote procedure calls. Number 2, the data transfer layer is extremely compressed. That data transfer layer is called protobufs, which we'll come to eventually. But if you use gRPC, your data transmission, number 1, becomes fast. Number 2, becomes extremely compressed, and that's how your cloud costs go down. Cool. This is the original approach. There are some flaws in this approach. There are no types, so hard to catch errors at compile time. We use JSON, which is really slow. We have to know what Axios is. You might say, you're a developer, of course you know what Axios is. Yes, this isn't a very big benefit, but still you have to write all of this ugly logic, figure out the URL, and a function call is much cleaner to write. Not language agnostic at all. If I have to make this call in Rust, I have to rewrite all the request logic in Rust. And I have to know how to do HTTP calls in Rust, so on and so forth. So it's not language agnostic. Let's try to do a quick HTTP request to this. So this is our classic sum server, sumserver.100xapps.com/todos. It returns you a list of random to-dos from the backend. And if I try to hit this, in a Node.js process by doing const response equal to await axios.get and do a get call over here, the data that I get back, as you can see, the inferred type over here is any. The front end does not know what the type is. And, at compile time, you can't really enforce a type. That is one of many bad things with normal HTTP. You don't need any of this for a long time. HTTP works and JSON works, but at scale, since we are at 1/200, this is one optimization that you will do when you have a lot of requests per second, basically, and you want to reduce the time to serve those requests and reduce your infrastructure costs. Before we get into gRPC, let's understand RPC. This is gRPC is one type of RPC, but tRPC is another one. There are various ways you can do remote procedure calls. So let's understand what is a remote procedure call. The name sort of gives it away. What if we could auto-generate a client that a Node.js server can call a function on the other service without worrying about the underlying Axios and a fetch call? Client is a new term here. In fact, auto-generated clients is a new term if you have not gone through the OpenAPI spec class. Auto-generated clients basically mean some code like this. What if some code like this could get auto-generated? A function called getToDos, which under the hood does this and gets the response and returns the to-dos. Also defines the type. This is going to return an array of to-dos where a single to-do looks like this. Wouldn't it be nice if somehow this code is auto-generated? How is it auto-generated? We'll get to eventually. But it would be nice if, this code is already written and I as the developer don't need to read any of this. I can simply do this. Const to-dos equal to await get to-dos and log the to-dos. To-dos also gets a type. As you can see, it's returning a type. Harkirat, what is this promise of to-dos? If your function is asynchronous, basically, then it doesn't return to-dos array. It actually returns a promise. And the final thing that it returns after the promise resolves is to-do array, which is why, you have to write this syntax if you ever have an async function. If you have an async function, you cannot say it returns to-do array. It will give you an error. Yeah, this to returns a promise. And hence, you have to return a promise and you can give the final type of the thing that's being returned inside this generic. That is what this part is. If you don't understand it, Google after the class, fairly straightforward. This is what you could technically say is a remote procedure call. You called a function which under the hood remotely called a function somewhere else, got the response back and gave you the response. So what is this? This is a remote procedure call. You calling a function somewhere else and it doing the thing, getting back the response. What is the benefit of a remote procedure call? Given this code is auto-generated. If this code isn't auto-generated, then it's the same problem. The developer had to write this code. Then it's just structuring your project. This is beneficial if this code is actually auto-generated somehow. Somehow this code gets, if somehow the other side, whoever is the developer of this, code has written some file, for example, an OpenAPI spec file, if you remember, and then this client gets auto-generated, then it is beneficial. Otherwise, if you have to write this code, then it's just structuring your project. It's not really, remote procedure call. It's still a remote procedure call if you look at this, but if you had to write this code, then, this isn't very beneficial. Then you would just write the same code over here, right? Then why do you have to create a separate function? Benefits: better types. If somehow this code is auto-generated, you get better types on the client. This to-dos, if I hover over this in Replit, it will give me the actual type, which is an array of to-dos. We are still using JSON, but we'll fix that soon. RPCs don't necessarily always have to compress data. Even if you're using JSON, it is still fine and still gives you some benefits. We don't need to use Axios anymore, and all you have to do is do the function call. So a lot of this underlying HTTP logic is hidden from you. And lastly, if we can get an auto-generated client for all the languages, then this becomes language agnostic. If this person has written some file where they've described the shape of their data, right? Very similar to an OpenAPI spec file. Then given that file, you can automatically generate not just a Node.js client, but also a Rust client, also a Golang client. And if you remember from the OpenAPI spec class, it actually does happen. Given an OpenAPI spec file, you can generate clients. What is a client? A file that looks like this. You can generate these clients automatically given the OpenAPI spec file. And similar thing happens over here. Okay, if you can somehow auto-generate it, you have a language agnostic client, irrespective of which language you have written your code in. You can auto-generate code like this. For example, in Rust, there will be a get to-dos function that, let's say, gets auto-generated, which also under the hood is sending out an HTTP request, getting the response and returning it. Same for Golang. And if these are auto-generated, then great. You have remote procedure calls exposed on this HTTP server. Whoever is your client who needs to talk does not need to call, an HTTP, doesn't need to do an HTTP call, can simply call a function and is good to go. The thing on the left can be a Node.js process, a Golang process, a Rust process, doesn't matter. So that is what RPC means. And we have implemented a dumb RPC over here. I somehow wrote this code and then this can be used. So this is like one trivial implementation of an RPC. Before we proceed into RPCs, even though we should probably first go there, let's first go to slide number 4 and then we'll come back to slide number 3. Yeah, let's go to slide number 4 first. Some common RPC protocols. So this isn't something I'm introducing. This is fairly commonly used. In fact, if you ever have tried to interact with the Solana blockchain, if I go over here in my wallet and try to send some money to someone, if I click on send, Solana select another wallet and click on review and then finally click on accept, the HTTP request that goes out looks something like this. Look at it. There is a URL and notice there is no route in the URL. It doesn't say /send money. No, it says here URL will remain the same. But here in the body, I'm writing something. I'm saying JSON RPC version 2.0, which means I'm using some protocol, or at least the server on the other side is following some protocol, some JSON RPC protocol. And this is the version of it. Ignore the ID. This is the method I want to call on the other side, get balance. And these are the arguments I need to pass on that function. Whenever you're doing a remote procedure call, under the hood, the request looks something like this. Even Solana and Ethereum, whenever you're interacting with the blockchain, you will find something similar. Okay, you are actually doing an RPC, a remote procedure call somewhere. It doesn't expect you to give a /transfer or /get balance as the route and and some arguments here. It says your URL will remain the same. You are going to follow the JSON RPC format. Give me what function you want to call. Give me what parameters do you want to call it with. For example, here I said give me balance of this specific address. And the response that I got back was again following a certain format. Hey, I'm still following JSON RPC. This is the result. And the value of the number of Solana that this person holds is 0.01 Sol, which is, this number if you multiply it by 10 is per 9. So this is commonly used. RPCs or, doing remote procedure calls is a commonly used format specifically here. And this is how we will finally write our code as well. There will be a single URL and somewhere in the body, you'll be telling what method to call and what parameters to call it with. The dumb server that we created a few slides ago, it's not the right sort of implementation. It's very dumb because you have a separate route under the hood. But usually when you're doing RPC calls, the thing that you tell is, hey, this is the function I want to call. This is the arguments I want to call it with. There is no HTTP logic over there. This is the route I want to call and this is the body I want to send. Cool. So we'll be writing this code very soon in case you don't understand it. But you'll find JSON RPC is one implementation of remote procedure calls, and there are many other as well. But yeah, this is basically a commonly used call it term. Basically, RPC is a commonly used term, and there are various implementations. JSON RPC is one, gRPC is one, TRPC is another one, and each solves its own sort of purposes. JSON RPC is just if you don't worry about the data going in JSON because JSON is expensive, but if you don't worry about it, then use JSON RPC. You will get the benefits of RPC minus the benefits of compressing your data. This is how you can create a dumb RPC server. Let's quickly go over this code. Should be fairly straightforward to understand actually. It's an Express server, has body parser. We do a app.use body parser.json so that all post request bodies can be parsed. We have a function here called add, which takes 2 arguments and simply returns a plus b. This function is pretty independently defined. And then we say, hey, anytime a request comes to /RPC, right? Parse these 4 arguments, JSON RPC, the method that the user is trying to call, the parameters that they're trying to call it with, and the ID. If you remember, what were the input parameters I sent? JSON RPC, which is the version of JSON RPC you're trying to hit, ID, method, and the parameters that you're calling it with. So if you want to create a dumb implementation, there are libraries that let you do this very easily. I've just written it fairly raw. Okay, I've written an endpoint that parses all of these things, checks if the JSON version is actually 2.0, checks if the method that they're trying to call is add, and if it is, then gets the result and then finally returns the result to the user. That is one way to create a JSON RPC interface. If I have other functions over here, I can define them and I can, add more case statements here. If they're trying to subtract, then do this. If they're trying to do something else, then multiply, then, result would be multiply params 0 and params 1. So this is a fairly dumb implementation of an RPC. Let me quickly, if you want to try it out locally, basically, is this clear? Is this straightforward? The implementation here. I guess the better question is, should we run this code and understand this better? Should we run this code and understand this better? Yes or no? Should we run this code and understand this better? Yes. All right. So let's run it. Let's see a dumb RPC implementation, a dumb JSON RPC implementation. Let me copy this. Let me go to projects and create a new folder called JSON RPC implementation. here let me do a npm init -y to initialize it. Oops, crazy. And then npm install express to add express. And lastly, v index dot, is this a TypeScript code? No, this is JavaScript code. So I can simply do index.js and paste it. And lastly, npm install body -parser. What did I do? I did things fairly quickly, but let me quickly explain. I created the folder. I created a index.js file. I pasted all of the content from here into the index.js file. And then I did a npm install of all the dependencies, which we have two right now, express and body parser. If I run node index.js and go to Postman, you will see in the past, I have made a bunch of JSON RPC calls to, Solana. If I make this call to Solana mainnet, some URL, which is, a Solana server URL, and pass some arguments in this format, it returns me some response. Okay, this specific Solana address, if you call get balance on it, the value is 0, which means the response is 0. This person has 0 sol. If I replace this with http://localhost:3000/rpc and send the same version, send the same ID, method is now going to be add, because if you remember, what method does my server support? My server only supports one method. Whenever a request comes, we check, hey, the method that was sent, is this method add? And if it is add, we call the add function and return the response to the user. But if it isn't add, then we say, hey, this method does not exist yet. If in the future we add more methods, we'll of course add more cases over here. Parameters, how many parameters do we need to send? What happens with parameters here? They get parsed and then we pass them to the add function. So I can pass, let's say 1, 2 over here. If I send this request, it returns me the result called 3. So Harkit, this is an HTTP call only. You just change the format. Yes, but technically this is an RPC. How, Harkit? This follows a certain format. If somehow I exposed all of these functions, right? I wrote in a file, here we have an add method that expects 2 numbers and a subtract method that also expects 2 numbers. Then a client like this, this can be auto-generated. A sum function can be auto-generated, which under the hood sends the request and gets back the response. And you can simply use await sum rather than worrying about all 4 of these things. I have to send a method ID, params, so on and so forth. So that is how you would follow the JSON RPC format. What is the JSON RPC format? It is one standard. Okay, if you want to do RPC, remote procedure calls, this is one format you can follow. As we saw a while back, the Solana blockchain, if you want to send queries over there, they also follow the same format. ETH also does. And we also made a similar server. Of course, we had to write it in a very weird way. And there are libraries out there, I'm sure in Node, that let you, do this slightly easily. We wrote a very raw implementation. Here, anytime a request comes, you parse the method and do all this. I'm sure there's a library out there that, you simply define your methods, it exposes it over JSON RPC. Do we understand JSON RPC, which is one RPC implementation? If you're thinking, what is the benefit of this? Oh, we don't understand it. Sort of understand it. 77. Taking a break, guys. Before we move to gRPC, we should understand RPC. Looking at Q&A. Reshare. Let me reshare. TRPC versus JSON RPC, which is better? They solve different purposes. TRPC solves a different purpose. The purpose of TRPC is you get similar types on the front end and the back end. The purpose of JSON RPC is you talk via JSON, yet you have a remote procedure call that you can do on the other side. So there's no better or worse. There are like different things to compare. How do you know to put params like this? Oh, you are doing a function call, right? When you do a function call, what do you send? The name of the method and the arguments. How many arguments does a add method need? It needs 2 arguments. And hence, the parameters that I'm sending are 2 of them. When you call a get balance function on Solana, if you actually call this, how many arguments do you need? The get balance function, wherever Solana has defined in a Rust program, let's say, it'll just have 1 argument, and hence I had to send only a single parameter. So it depends on how many arguments does the function have, which in our case, the function had 2 arguments, and hence I sent 2 parameters. Difference between GraphQL and RPC, if they are both using methods under the hood to fetch data. GraphQL is a query language. It lets the user specify, I need this, and this, and the server sort of returns just that much data. That is the benefit. That is why why was it introduced? GraphQL was introduced because people at Facebook were like, yeah, if someone sends a post request here, we to return them all the data. If let's say this request is sent, see daisy, then you get back this big object. What if the user only needs this? So in GraphQL, you can specify, I only need ID. I don't need anything else. And the backend will only return you ID. This is great because you can restrict the amount. If you don't need something on your front end, you can restrict and tell the backend will only give me this. It also lets you ask for multiple things together. You can, if you're using GraphQL, you can say, hey, I need the user details. I also need their orders. And I need how much money they made, whatever. You can, in a single request, specify everything. You can't do that in JSON RPC. I cannot say, let me do some as well as let me do, subtract, and here are the arguments. So they solve different purposes. The purpose of RPC is to hide the complexity of HTTP from developers. The purpose of GraphQL is to let the developer specify on the front end before sending the request. Here, this is what I need. A lot of recaps, which we can do. I will look at a few more questions and I will of course recap. I've seen this type of functionality in daily code, GitHub, which uses Firebase functions. So Firebase functions are a remote procedure, a good way to describe remote procedure calls. When we had Firebase, we've removed it, but yeah, over there also you call a function which under the hood is sending out an HTTP request. So in Turbo Repo, we don't need TRPC. Both front and backend can access types. Sort of. TRPC is still good if you need very strict types on both the sides. Then TRPC will help. Yes, you don't need them if you use Turbo Repo, though technically. What is the difference between OpenAPI spec and RPC? OpenAPI, they have similarities as well as differences. OpenAPI spec says, if you have a server, right? OpenAPI spec says, if you have a server, along with whatever routes you've written, app.get, this is your server, write one more file which describes there's a /endpoint that does something, so that you can auto-generate clients, and sure, these will have functions that you can simply call. So yes, you can sort of say, this also gives you remote procedure calls, but here the backend doesn't follow a certain format. You can write whatever code you want. You can have whatever routes. It depends on the developer. I can write, route 2, or I can write something else, route 3. I just have to describe it in a file, and this also auto-generates clients where you can simply do function calls. So yes, this also gives you the same benefits. But what can you not do? What can you not do over here? What is the difference? Why is RPC better over OpenAPI spec? One thing I can think of is, it follows a certain format. As you saw here, every request needs to look like this. It needs to have a function name as well as some arguments. Versus here, you can write whatever code you want. That is the only sort of difference I can think of. Sure, you can totally write whatever code you want as long as you have an OpenAPI spec file. You generate functions, and you have the benefits of auto-generated clients. Wouldn't our API endpoint grow definitely if we use the JSON RPC server, RPC on our server? What does that mean? Slides, you just have to go to this URL. They are not visible on daily code. There's some bug. So just go to this URL. All right, a few more questions, then we'll proceed. Then I'll recap and then we'll proceed. Is blockchain then a centralized RPC node? No. There are a bunch of nodes. Each one of them supports the RPC protocol, gets the thing from you, and broadcasts it to the blockchain. It is not a single RPC server. What is the meaning of auto-generated clients? Great question. If you are able to generate such a file automatically that looks like this, then that's called an auto-generated client. If this is my index.ts, and inside this, I only have to do const todos equal to await get todos, which as you can see under the hood is sending out a request. If this file can automatically be generated, you can say my client, my thing that is trying to ask something from the backend was automatically generated. This function was not written by a human. This file, you ran a command and this file got spit out. That is what auto-generated clients mean. If I have a backend server And in a file, I describe all my routes. Here there is a route /route, which is a get. There's a /route1, which is a post, so on and so forth. And the body that they have, the response that they give back. If I write all of this in a file, then the file can be parsed and you can create all of these functions automatically. Okay, this has a add to do function and remove to do function, so on and so forth. So that is what a auto-generated client means. Okay, given a file where you've written the shape of your HTTP server, you don't need any implementation here. Implementation is in a Node.js process or Node JavaScript file, but you also have a openapi.yaml file where you have written all of this. Okay, our backend supports by this. Then you can automatically generate clients from them. What are clients? Basically a bunch of functions that you can directly call rather than worrying about, I have to do axios.get or axios.post. So that is what a auto-generated client is. Let me recap what we have done and what we were supposed to do today. Sort of, stuck in the middle here. We are supposed to do gRPC. But before we reach gRPC, we need to understand RPCs, which is remote procedure calls. What are remote procedure calls? If you have multiple servers all around the world, microservices, you might have heard of this. You have multiple services that need to talk to each other. Then how can they talk? Harkirat, pub subs, queues, yes. Ignore them. You have to directly talk and get back a response. Then Harkirat, they can talk via HTTP. Yes. Let's say this backend server has a sum function that, lets you calculate the sum of two numbers. And this person or this server needs to use that function. How will it use it? It will send an HTTP. Harkirat, you can just write the logic here for a sum function. You can, but you shouldn't. If that logic is here in a central place, this guy should just use that logic. This guy should just call a function over there. How can one Node.js process tell another Node.js process, okay, please do something with these arguments and give me a response? One way is this. You can write an HTTP server here. You can write axios.get, axios.post over here and, do HTTP calls. But why is this bad? Here are a few reasons why it is bad. Explained in the beginning and, just read through them. Basically, simplest reason, you have to write so much code. This is so ugly to write. Axios.get, you have to go over here, look at the route, put the route over here and, write all of this implementation yourself. What if you could get a automatically generated client like this, where, a get to do's function is exposed and you can simply do this? What if whoever was the developer of this second service was also forced, okay, bhai, if you're writing this, also write the client. What is a client? A JavaScript file that other Node.js processes or other Node.js developers can use and simply call a function on them. Something like this. Wouldn't it be nice? It would be nice. What would this be called? This would be called a remote procedure call. You just as the developer wrote get to do's, but this function isn't in your process. This function under the hood is sending a request, getting back a response and returning it. That is what a remote procedure call is. It is nothing. It is an Axios call only in the end. But you as the developer don't have to write axios.get or remember what the route is that you're hitting or, figure out the types or the input to send. You simply call a function and, get back the response. Of course, this function call is actually happening somewhere on a different server. You're getting back the response and then, finally storing it here. So that's what a remote procedure call is. Then we came to this slide and understood RPC is a pretty common implementation. A lot of people use it. And one good example here is blockchains. If I ever open a wallet and, even look at my balance, that is also, if I, inspect element here and look at all the requests that go out, they probably get proxied, so you'll probably not see them here. But that is also a request that is going out to a server that looks something like this. Get balance for this address. And, this one follows the JSON RPC format. JSON RPC is one RPC implementation. gRPC is another one. TRPC is another one. There are various libraries that have been written that all let you do remote procedure calls. Harkirat, how is this a remote procedure call? This is a remote procedure call because you are not saying I want to hit this specific route. You are saying I want to call this specific method with these arguments. And then there is a function defined somewhere called getBalance that gets called with these arguments and you get back the response that looks like this. That is why this is a remote procedure call. And specifically, since you're sending JSON and getting back JSON, this is a JSON RPC. Now, do we understand what is, then we implemented an RPC, which, feel free to ignore. Of course, the people who are at Solana haven't written this in JavaScript. They've most probably written it in Rust or C. So, if you look at that server, you will not find functions like this. This was just a dummy implementation of JSON RPC. Are we good to go, guys? Do we understand the benefits of RPC, how do you create a simple JSON RPC server? Didn't move too much. 85. Okay, let me look at Q&A for like 5 more minutes and then I'll proceed. Where are we sending the params? PARAMs right here. If I open Postman, if I look at this request that I'm sending, this is the method I want to call, and these are the arguments I want to call it with. Params is an array where I can pass multiple arguments. If the final function also has multiple arguments, in this case, the get balance function in Solana, wherever it is implemented, looks something like this. Function get balance, and address for which you're trying to get the balance has some implementation, and then finally returns some number, which is why when I'm calling it, I'm saying, hey, I want to call the get balance function with these arguments. Now, since this only expects one argument, I'm only sending one, but there might be some other function that requires 2 arguments. Then I could send, in this array have 2 arguments right here. So that's how you send parameters. So this will help me make crypto wallet. You have to understand how to make RPC calls. You necessarily don't have to build the backend. So yes, it will help you understand or parse these, I guess. Yeah, you should know what JSON RPC is, but nothing more than that. It will help you create a wallet though. Yeah, sort of. When will the server action in Next.js? Does RPC framework make sense except the expensive JSON format? Yeah, you could say that, right? That is a prime example of an RPC. Okay, you do a function call and it goes to the backend. Do you need this? That's a Next.js specific thing, right? So what if you want to write your backend in Go? Then you can't really use server actions. So what if you want to have different front end and backends? Then you can't use server actions. So yeah. What is OpenAPI? We have a video on it. Difference between gRPC and tRPC. tRPC can only be used in a Node.js process. gRPC can be written in any language. So that's the one difference, and they serve different purposes. tRPC was written so that, if this is your front end and this is your backend, and they are both in Node.js, which means front end is in Next or React, and backend is in Node.js, let's say, then you can of course define a function sum over here that you can directly call over here. That is why tRPC was introduced, and it gives you nice types on the front. I think the T in tRPC stands for types. I could be wrong, but it can only be used if your front end and backend both are in JavaScript. But gRPC, number one, provides a lot more benefits than just tRPC, and number two, can be written in any language. When we have server actions, okay, so that, how will this help in scaling? JSON RPC won't. gRPC will. We'll get to why that will be though. Can you explain me how RPC request is decided? Okay, this is blockchain related. Basically they've written, that depends on the developer, right? If they had to write, give me the balance function, then that would have been the function name. That would have been the function name written here. So it just depends on what they wrote, which is like a meaningful thing over here. Alrighty, let's take a pause and do a very small recap and proceed now. To quickly recap, we understood since the beginning of the class, whatever we're learning now is sort of disjoint of what we've learned. So it's fine if you did not understand anything, even though like 85% is good. We understood what are remote procedure calls. Someone mentioned server actions are remote procedure calls. Yes, they are. Someone mentioned, I mentioned tRPC lets you do, is sort of a remote procedure call. Yes, it is. gRPC, I said, is something we will learn today. That is also sort of a remote procedure call. It lets you simply call a function on one side, and that under the hood gets your response from somewhere else. JSON RPC is something we learned about, which a lot of blockchains follow. We also built a small implementation. There is no benefit of these in scaling really. If you're using JSON RPC specifically, you're still sending JSON, getting back JSON, rather than sending something in the route. Okay, I want to do a get balance. You are sending it here as the method parameter. So there is no benefit in scaling if you're using JSON RPC, for example, but there's a lot of benefit in gRPC. Let's understand why. Let's understand what is gRPC and why is it better to use gRPC over JSON RPC. If they both solve the same thing, if they both let you do remote procedure calls, why is gRPC better? Let's come to slide number 3 now. Again, slides are not present here, so just paste this URL. Let me paste it in chat. Before we get into gRPC, we need to understand what are protobufs. How many of you have heard of protobufs? It's a common thing used in big companies from time to time, even in small companies. In fact, my very first GSOC sort of contribution was in a library for company called OpenStreetMaps, which used protobufs. Okay, that's a good 50-50 blend here. Protobufs, and you can read about them here, but basically are Google's language neutral, platform neutral, extensible mechanism for serializing structured data. Think like XML or JSON. They are a way in which you can somehow compress either a JSON, an object, your data in some format, send it to the other side, and then the other side can decode it. You don't also have to send it on the other side. If you want to ever store some data in your file system, you can store it like this, right? Okay, let's say you want to store your friend's name, then you can be like, Achha, I will store an array that looks like this. Okay, my first friend's name is Harkirat and age is something. This is one format to store data on your machine. Another might be simple text. Okay, Harkirat is a friend of mine, his age is 22. Another Raman is a friend of mine, his age is 22. So you can store data on your file system either in text format, or you can extremely compress it. You can convert this into, you can zip it. You've probably zipped files in the past. It creates like a, persons.zip file. And what is the benefit of zipping a file? The size becomes really small. Protobufs are a similar thing. Okay, you can define your data in any shape or form. It could be an array, could have strings, could be a map. And then the final thing that you can store or transfer to over an HTTP wire is extremely small. This becomes beneficial when you have scale. If you have 1 million users sending you requests every day, and if the requests are coming in JSON, then number one, your bandwidth costs can be really high because beyond a point you have to pay for bandwidth. And number two, JSON serialization and deserialization takes a really long time, or is very expensive on the compute. Versus if you use protobufs, I could be wrong here. Maybe they're expensive when it comes to compute. Most probably they aren't. But at least the size that goes over the wire is really small. That is why you use protobufs. For use cases where you're going to hit a lot of requests, or if there is a specific request that's getting hit a lot, or if you have a service that end users are hitting and you have 1 million users, then rather than transferring JSON, you transfer protobufs. Protobufs have nothing to do with gRPC. gRPC is something else. You don't need gRPC for protobufs. They're an independent thing. Just like XML, just like JSON, a third format to either store data or transfer data is protobufs. The protocol buffers are where we define the service definition and messages. This will be like a contract or a common interface between the client and the server on what to expect from each other, the methods types, yada. Basically, it's something very similar to an OpenAPI spec file. Whenever you want to use PBFs, create protobufs, you have to first describe the shape of your data. Okay, this is what my data is going to look like finally. Be it you want to use it in an HTTP server, or you want to even use it to store data, you first have to describe your schema. Okay, my data will look like this. This is the version of Proto that I'm using, Proto 3. I have a person object which has a name and an age. Ignore this equal to 1 and equal to 2 for now. I have a person who can have a name as string and age as int 32. Ignore this as well. Maybe ignore this as well. Just focus on this much. This much syntax is enough for you to store a person object on your machine in a very compressed manner. If I copy this over and go to this website right here called protobuffpal.com, I can tell it, hey, I want to store, I can paste my proto definitions here, my schema over here, and I can tell, hey, this person thing I want to store, this is my decoded message, which means this is how I would store this person usually. Name is Harkirat, and then age is, let's say, 32 or 21. If I click on encode, invalid JSON, this is how my final thing is stored. Harkirat, how do we know if this is small? This is small. We will come to this eventually. But rather than storing this on my file system, wouldn't it be nice if I can store a very small encoded thing? As long as this can eventually be decoded. If I remove this and just have this, if I click on decode, it gives me back the JSON. So as long as this JSON can be fetched back from this compressed data, wouldn't it be nice if I can compress my data somehow before sending it to the other side? And then the other side can, of course, decode it and get back the JSON. That is what protobufs let you do. They are a format for you to store data in an extremely compressed manner. How do you define your format? Why do you have to define your format? Why can't I just give a random JSON over here? It expects you to give the format. It in fact expects you to give extremely granular detail of your types. Okay, the string name equal to 1. I'll come to what this 1 is, but the reason you have to give this 1, 2 on each and every field is because when it's compressing data, these are called field numbers basically. Let's start from the top. What have we learned? Protobufs is a format to store data or transfer data over the wire, which is better than JSON. It compresses your data a lot. It's like zipping your data before storing it, let's say in your file system. And the way to define your schema is first you have to describe the shape of your data. We just focus on this. No need to focus on this, even though this should be straightforward to understand, but let's ignore this. Let's just focus here. You first have to describe the schema of your data, and then you can, take any data, compress and decompress it. What does the schema have? Number one, it has this thing called as a message. A message basically, where is that screenshot? Oh, I didn't keep it finally. Never mind. A message basically is the data that you would want to store or transfer ever. So if you have, an e-commerce website, then there would be a message called catalog. There would be a message called items, a message called cart. If you have a game, then you'll have a message called characters. You will have a message called direction in which you're moving, so on and so forth. Anything that needs to be transferred over the wire, any data that you want to store, you create a message for it, you give it a name, and then you describe all the types. This is like an object, right? An object in JavaScript. Okay, this is a string. The only weird thing is, why are we giving every field a number? Okay, your number is 1 and your number is 2. If you look at this other message that I have called get person by name request, there also I'm giving it a number. And the answer is, these are called field numbers. And the reason you need them is because you might change your schema, right? You might move this up in the future by mistake for some reason. So these numbers are attached to every type. So whenever your data is being encoded and decoded, it remains backward compatible. If you by mistake move this below and move this up, your compression and decompression will completely change unless you have some number attached to every field, which is why you need these sequence numbers. Usually you'll see them go from 1, 2, 3, 4, 5. No one, complicates this at all. You'll give the first one a field number of 1, second one a field number of 2, so on and so forth. So this is just something extra you need to do whenever you're creating protobufs. Again, this is just protobufs we're discussing. We have not yet reached gRPC. Just how do you store data in a compressed format, specifically the format being PBFs. We've understood this. Let's try to store some data on our file system and, in a compressed manner, and then see, does it really give a benefit? Basically, whatever this website is doing to convert, this to this, I've written some Node.js code that lets you do the same thing. We don't have to do it. If you look at the code, it uses this library called protobuf.js, which pretty much, if you give it a schema, for example, if you give it a.proto file, which is this file right here, and you tell it, hey, I want to create a person and I want to encode it in this person message, and you store it in a file, you can look at the contents of the file. They look very similar to what you see over here, and you can actually see the size of the file compared to a JSON file. You can also read back this file. That's what I'm doing here, and then decode it back to a JSON and log the JSON. Basically the same thing this website is doing. I've written the same code here in Node.js to do the same thing. Load a proto file similar to how these guys are loading a proto file over here. Give it the path, then get the person message from there, which is the thing I had to do here, and click on person. Then create an in-memory person object, which is what I'm doing over here by pasting this. Then encode it, which means click on the encode button and get back the final contents that you see here. Then I also store these contents in the file. I can explore this file, look at it. It will be an extremely compressed file. I can also decode the data by reading from the file and then finally decoding it here in this variable. If I log it, I will still see the original JSON. If you compare the sizes, the PBF size would be 9 kilobytes compared to if you store the same thing in JSON format. If you store something like this in a file, it's 31 bytes. So as you can see, like 4 times the benefit when it comes to storing the file. It's pretty much just compressing your file. Do we understand protobufs and why they are used? They're basically, this website covers everything of why you need a protobuf. You need it to compress data Only before you compress data, you have to describe your schema over here. And only then can you compress and decompress. The other thing that I sort of ignored was along with the message, it lets you define one more thing. This one more thing is called a service, which, as the name suggests, microservices. What do you do when you create multiple frontends and backends? You create microservices. What was the thing that I saw in the first slide? These are 3 different microservices. So what would this service section be? It basically means what all functions does this service support. And you can say, hey, it supports a remote procedure call called add person, which takes a person as an input and returns a person as an output. And similarly, a remote procedure call called get person by name, which takes this other message as an input, which, has a string basically. So it takes this other, you can't simply write string over here. Basically, you have to create another message and say that the input is this other message. And this returns a person if a person with that name actually exists. So this is very similar to the OpenAPI spec file. You're describing all of your schemas and you're describing all of your methods. So if you look at this file, it's actually just the format is different. That is a YAML file. This is a proto, their own schema, but both of them let you describe your final service. Of course, there is no implementation logic here. Okay, how do you implement these functions? What does add person do? What does get person by name do? We haven't written that, but this file, you can describe your messages as well as your services. Do we understand how to create a proto file and why is it used? What are proto buffs? And this message, we haven't transferred this message over the wire yet. We have just stored it in a file. But do we understand the benefits of proto buffs? Sort of do. 78%. Let me look at Q&A for 5 minutes. I wouldn't have thought this would be this difficult a concept, but we will look at. The bin extension is not necessary. You can store it in whatever format you want. Is protobuf.js like sending the metadata of the implementation from one service to a caller service? No. Protobuf.js, at least over here, is just compressing it on my own machine. Similar to how when I click on the encode button, how it takes this data from my machine, my browser, and puts it over here. Similarly, protobuf.js is right now taking this person object and storing it in my machine. It is not storing it, sending it over the wire yet. What are services? So protobuf is actually just a data compression library. You use it for data compression. You don't really use it for services. It lets you define services though. KR, if you ever, so why was PBFs introduced? KR, we need to compress data. But why was this data compression needed at that point in time? You already have zip. It was needed because whenever you do RPCs, you send a lot of data. You send JSON data, which is bad. So whoever wrote, this is my assumption, maybe they wrote it with a different thing in their mind, but whoever wrote proto, assume, they said, of course, you should describe the data, but eventually this will be used in a RPC framework, right? Or it will be used in an HTTP server. So along with describing your schema, describe your services, describe what all methods does your backend support. If you are going to create an RPC backend, what all methods will it have? What all methods can people call over there? And what inputs do these methods get? What outputs do these methods get? Let's say you're creating a simple person service where someone can come and register themselves. Okay, hey, my name is this and my age is this. And they can get back their details. Okay, hey, this is my name. Can I get back my age? So these are the 2 functions that our backend needs to support, or 2 remote procedure calls that our backend needs to support. We have just described the type here. The implementation of these can be done in gRPC or can be done in some different RPC framework. But protobufs don't care about implementation, specifically of implementation of services. They let you describe data, they let you compress data, they let you decompress data. They don't let you describe any Node.js logic for the actual implementation of these 2. That implementation you can do in any language of your choice, be it Golang, JavaScript, Rust. It gives you very nice constructs to do those implementations. Finally, by constructs, I mean, given this file, you can auto-generate a bunch of code and just use, or at least auto-generate a bunch of types. If you go to the final slides, you will see when I write adding types over here, given this file, it will generate a bunch of TypeScript code for us that we can simply use in our Node.js process. So protobuf, like the benefit of describing this service is you can auto-generate a lot of code, but yes, protobufs have nothing to do with the service. They only worry about the message and compressing the message and decompressing the message. Let's look at a little more Q&A. Code execution. Let's quickly execute this code. Let's copy this. Let's create a new file called index2.js. Let's paste it. Let's do a npm install protobuf.js. Let's do node index2.js, and you will see it says file doesn't exist a.proto. I need to create a a.proto file. Inside the a.proto file, I will paste either all the code or even this much is good enough because I'm only using the person object. I will rerun index2.js, and it says person serialized and saved in person.bin. If I do a cat person.bin, it'll probably show me, whatever the contents are, which it says. It shows me Alice over here, but it's compressed in a certain way. The number is also somewhere. The age is also somewhere here. You just cannot see it. You can also, convert this into hex or, whatever the formats were on this website, base 64 or hex, and, look at the final thing here. Of course, from the naked eye right now, you can tell, but as your data becomes very big, you won't be able to, decode or understand this data at all. This is a very simple object, which is why you're able to see Alice over here. If you look at the size of this file, the person.bin file, you can call it person.txt, does not matter. It's 4 kilobytes. It's actually 9 bytes. It's stored on my OS for some reason, but it is, the real size is 9 bytes only. Versus if I store a.json file, which has this contents right here, and look at the size of an a.json, you will see the size is 28 kilobytes. So slightly higher. You can also compress this a little bit more. This will only, if I really want to optimize my JSON, I actually can, I can remove all the spaces. That will reduce the size a bit, but at scale, so I can agree, if I want, I can reduce the size of my JSON, but not beyond a point. Beyond a point, you need to compress somehow, and PBFs are one way to compress data. Why can't we compress? You can compress using any generic compression framework. The problem is, how will you write your code? Will you, in your server finally, let's say this is your server, what will you do? You will be like, okay, I'm going to return the data, and you'll do a something.compress. You can do that, but you'll have a lot of application logic, which will have, let's say, the gzip library. You can do that. But when you're using gRPC, you will see you don't even have to do it. It automatically converts your data into PBFs on both the sides. So, but yes, you can manually do it as well, and use a different compression format. JSON is extensive in storage. Is PBF time consuming? If your question is serializing and deserializing protobufs time consume more time, this is something I even want to PBF versus JSON time to compress. Seems like it isn't, but yeah, read about it. Basically, it is definitely less in storage. I would assume it is easier to parse as well, as in the time it takes for a server to parse a JSON versus a PBF. PBF is lesser, but read about it. This is something I wouldn't quote. What algorithm is used by DRPC / protobufs? No idea. Probably have their own sort of algorithm to compress, or maybe there is some standard algorithm they follow. No idea. Never looked that deep into it. Can we do nested compression for more compress? What is that? What does nested compression mean? Keep compressing? Okay, let me do a poll now. Are we good to go, guys? Can we proceed to gRPC given we sort of understand protobufs? Alrighty. Great. 90% is great. Let's proceed to the final thing, the real thing we had to learn today, which was gRPC. Types in PBF. This is a more comprehensive list of things you can put in a protobuf file. You can have int32, int64, unside ints, unside int64, float tuple, boolean, all that jazz. So, these objects can be extremely complex. You can also have arrays. Let's see. If you ever have a person object which has, multiple phone numbers, which are a string, you can write repeated over here. And then the final thing that is generated, the final thing that is expected here is an array of strings. So it pretty much lets you describe any shape of data. And has a bunch of these primitive types, not just integers, but floats as well, not just floats, but strings as well, boolean as well. You can also store bytes if you want. It also has this concept of enums, which same as enums in TypeScript, same as enums in Rust. It lets you describe the variants of something. For example, this enum can be used where, should have had something else here. There you go. If I describe this enum called phone type, which can be, either mobile phone or home phone if you have a landline or work phone, you can use it over here like this, which means, you know, this type can only have 3 variants. It can either be 0, 1 or 2 basically, or whatever, phone, mobile, home or work. If you want to explore this, you know, just copy this and paste it here, and copy phone number, paste it here, and then, you know, try to encode the phone number. Okay, the phone number has a number which is, let's say, some long string, and then has the type which is, let's say, 2. So if I encode this, I get some compressed data. If I remove this and I decode it, it says the type is work, because when I was compressing, I compressed it using 2. If I compress it using 1, then of course it will return the same thing. Or if I compress it using home, then, you know, when I decode it, I will see the second thing over here. So like, feel free to play with all the types. There are not too many of them. This list is good enough basically if you have an understanding of all of these primitives, and enums in case you need it, maps in case you really want to get fancy, although I have not seen maps in most or any of the protofiles that I've used. And this is just a more complicated protofile if you'd like to look at it. But, you know, nothing different from what we already had, just that you can have multiple types, and you know, your protofile can be extremely complex. Let's proceed and you write some code. Let's start with, do we need a break, guys? It's 8 p.m. So just want to make sure, should we take a break before we move to core gRPC? Do we need a break, yes or no? Oh, oopsie daisy, bang in the middle. Slightly leaning towards a yes. Let's take a small one then. Let's meet back in 5 minutes. So let's meet at 8:10. I'll answer some questions until then. Looking at Q&A. Anything that is, let me just open chat, I guess that's easier for everyone. After the break, we'll simply be going through implementing, well, understanding gRPC first and then implementing it. Any questions? A bunch of them. Are protobufs BOSH compatible? I don't know. Good question. BOSH data is stored on the Solana blockchain. BOSH is just a library that lets you serialize and deserialize data. It stores the data in bytes finally. It isn't a format. What is this? Switch from BOSH to protobufs. BOSH was built major breaking change and punted for consideration. The main benefit, I can tell you, Proto is upgradability and baked into the IDL. The other benefit mentioned with respect to being agnostic programming languages and reading the accounts. This is the benefit of agnostic programming languages and reading credit, which is also achieved by BOSH plus IDL and currently implemented for Anger. So yeah, basically what they're saying is BOSH plus an IDL, which, you know, is the, what does IDL stand for? Interface Development Language, something like that, is enough. I don't know why they why this was closed, or was this closed? Is it still open? But yeah, what's your question again? Are protobufs and BOSH comparable? Oh, comparable. I would have thought before reading this issue they're not, but like, what is BOSH? Is it a data? I don't think it's a data compression. It just lets you convert things into bytes, I think. Binary object representation serializer for hashing is an implementation of the BOSH binary, which is, yeah, it's also a format, it seems. I would have, my assumption until this point was it's simply converted into bytes, but BOSH binary serializer, which sort of does for critical projects. BOSH stands for the binary of hashing. It means it can be used in critical projects as it prioritizes. Yeah, I would say after this, reading this issue, they are sort of comparable, and, you know, both of them compress data. I would have assumed, and this, I might still be right on this, okay, BOSH just converts it into bytes, and these guys, I would assume, you know, let you encode into the data into, like, they have their own algorithm of encoding the data. Good question. RPC is just a function call over the network rather than native function call, which means it's slower than native function call. Correct. Here comes gRPC, which uses protobufs to minimize the time of computation. Okay. Yes, exactly. So it's language independent. Yeah. We will be doing reviews at like 10 p.m. most probably on a YouTube live. I want to ask for TRPC, since the benefit was types, but it needed to be in mono repos, frontends and backends. And in frontend, we were importing types from. Can we still import types? Yeah, you can import types, but, you know, you have to explicitly import types from the backend and put them there. If you use TRPC, you don't have to do any imports. You change the function signature in one place, it automatically, you know, starts to throw an error in the front end. You don't need TRPC if you're using mono repos, but if you want like if you don't want to explicitly, even if you have a monorepo, you'll explicitly import the type on the front end, right? TRPC takes that away as well. So there's mild benefit. Although I've seen fairly minimal implementation of TRPC now. No one really uses it basically. Give a real life example where we need an RPC and where an RPC is not valid. Give a real life example of you don't need RPC. HTTP is good enough. So there's no, in this specific use case, you should use an RPC. There are use cases where you should use gRPC because it compresses data, but you can compress data yourself as well. Is there a clear example? Okay, here you should use RPC, here you should use Axios. And the answer probably is, if you have in your company a lot of languages, a lot of teams. Basically, this is very common in a big company like Goldman. Everyone is doing, RPCs left, right, and center because every team implements their code in their own language, and they can expose it over HTTP. But usually, at least this happened at Goldman. I'm assuming this happens in most big companies. You have a bunch of Java logic. This is team 1 that has written one Java project, and then there's team 2 that has written another Java project, and team 3, and all of them export / put their auto-generated clients or whatever methods basically that other teams can use, and they bring this, create in this Java code, and then just do a bunch of function calls, so that this client all it has to do is do a function call, for example sum, which of course under the hood sends an HTTP request and gets back a response. So I've seen this used fairly commonly in big companies which have a lot of services, and where you don't want to get into the logic of what are you actually writing. You simply want to call a function which under the hood somehow reaches here and gets back the response. That's one case where I've seen it used popularly. Can you still use it, do without it? Yes, you can always use HTTP and you don't need RPC. Alright, 8:10. I will be back in 2 minutes. I need to grab some water, guys. So 2 more minutes and then we'll start. Alrighty. What did I want to do? Just wanted to check OBS. Alrighty, that is good. Back in 2, guys. Alrighty, sorry about that. Let's proceed. Cool. Let's get into some coding now. Let's write a gRPC server. If you remember the Express class, the first class in which you learned about Express, this is going to be a similar class where we're going to learn about how to let people all around the world access some services of yours. Call some functions. If you have a sum function that you've written that takes 2 arguments, a comma b, and does some math on it, c equal to a plus b, and then returns c. If you have written this method, and let's say this is a very complex problem, this isn't, but let's say it was, or if you've written a lot of logic for a social media website, then you want to expose it over the internet for people to interact with your services. One way to do that is HTTP. Another way to do that is remote procedure calls or RPC. What are we learning? gRPC, which is, I don't know what the G stands for, probably stands for Google or maybe something else. But what are we learning? We're learning about how can people talk to your services. How can you create a gRPC backend rather than creating a HTTP backend. What happens when you use Express? You create an HTTP backend. What are we creating? We are creating a gRPC backend. What are the benefits of gRPC? We can get to eventually. But how do you create a gRPC backend? How do you expose functionality from it? Number one, you have to write a proto file. This is bare minimum. Okay, irrespective of what language you are writing your code in. In this case, we are writing it in JavaScript, but we could write it in Golang also. We could write it in Rust also. Irrespective of which language you are writing it in, you first have to describe this proto file. The benefit of one more benefit of gRPC is, as long as you've written this, you can implement this in whatever language you want. Can be Node.js, can be Golang. We'll be implementing it in Node.js. Let's say we have a very simple service. It has a message called person. It has a service which is called address book service. Don't ask why. And it lets you do two things: add a person and get the details of a person. This can be thought of as two HTTP endpoints, one for signing up, one for putting your details on a server, and another one for getting your details back from a server. Only rather than having two HTTP endpoints, these are two remote procedure calls. This has zero implementation. I have not written any logic over here. This is just the shape of my final service. I need to implement this now in Node.js. So first of all, make sure you have this file handy. Whenever we'll be writing the code, we'll be sort of needing this specific file. Implementing the services using gRPC. If you go to grpc.io, you'll basically find how you can, given a proto file, given a file that looks like this, how can you implement it in any language of your choice. You can create your backend in any language, and your backend will follow the same format. It will have two functions that people all around the world can call, and depends on you where you want to do the implementation. The benefit of using gRPC is at the center there is this proto file, and given this proto file, you can write your backend code in whatever language you want. Let's say Node or Golang or whatever other language, and whoever is calling it, right, it will give you auto-generated clients for those languages as well. If let's say you're making this RPC call from a Rust process, given this proto file, you can auto-generate a client. What is a client? A small file in Rust that has a function called whatever, add sum, let's say. This Rust process, this Rust file can simply call the sum function, and it will eventually reach whatever backend you've written. So it's highly language agnostic, both on the client side and on the server side. Given this single proto file, you can do an implementation in whatever language you want. You can call the RPC in whatever language you want. It will give you auto-generated clients for every language. What are we writing it in? At least the backend we're writing in Node.js. The clients we can write in any language, doesn't matter. We can see, we can do an RPC irrespective of the language. Let's initialize an empty TypeScript project, and then start to write some code. If you want to follow along, feel free to. If not, also that's fine. This isn't too much code that we'll be writing today. First thing you have to do is initialize a project. Let me create a fresh project here called gRPC week 24 npm init-y to initialize an empty package.json, and then npx tsc-init to initialize the tsconfig.json. This we've done many times, so I'm assuming this is fairly straightforward. I'm going to open this in Visual Studio Code next. Again, I've only followed step 1 and step 2 over here in a fresh folder that I created. File, open. This is the empty project that I have. If you want, you can go to tsconfig.json and change the root dir to be source and the out dir to be dist. Even if you don't do it, it is fine. We have a single file where we'll be writing all the code, so you don't need as good structuring at all. Feel free to put it though. What have I done? Initialized a package.json, initialized a tsconfig, added a out dir and a root dir. This thing right here, and then maybe create a source/index.ts file where we'll be writing all of our gRPC code. Also, you should have the a.proto file handy, or whatever you want to call it. You can call it, message.proto. I'm just going to call it a.proto because that's what I use throughout. First thing you have to do is copy over your proto logic in a .proto file. So I have source/index.ts and source/a.proto. This file, keeps on getting bigger as your application gets bigger. This is similar to the OpenAPI spec file. You maintain it along with your code. As your code grows, as your application grows, so does the a.proto file. If you in the future add another function called, delete user, let's say, delete user by name, then, you will add this to this file. If you support more endpoints or more RPC functions, then you'll have to describe more and more RPCs in this service. So you can also define multiple services, but let's not go there. This file will grow as time goes by, as your application size increases. This is defining the proto file. Let's describe the implementation next. Again, this could be any language, but we are going to use like JavaScript. This much code is actually enough to do that. The library that we're using is at grpc/grpc.js. This I think is an official library. We're also using a at grpc/protoloader library, which I think is unofficial. I think this is also official. This comes from at grpc. So both of these are official libraries that the grpc Foundation provides for JavaScript. They provide similar libraries for other languages as well. Let me copy the code and paste it. But before I do anything else, I need to do a npm install this is TypeScript. That's fine. At grpc/grpc-js at grpc/protoloader. Basically all the dependencies I need to bring into my code base. See if that fixes the errors. It does. So what did I do? I installed the libraries. This step was also present here as step number 3. So initialize TypeScript, initialize the Node.js project, initialize TypeScript, add the dependencies, create the proto file which has your services as well as your messages, and finally the code that we write that finally implements the gRPC protocol. Just how we have used Express in the past to create an HTTP server, we are using at grpc/grpc.js to start a gRPC server. It is a different protocol. Just how HTTP is a protocol that follows a certain format, and it's described somewhere in some file that this is how an HTTP protocol should look like. Similarly, gRPC is a protocol, and the library we are using to implement gRPC is at grpc/grpc.js. Are there other libraries? Probably, but this is the official one. The first thing you do is load the proto file by doing a protoloader.load sync. This means this will load it synchronously, which means the thread will be stuck here, which is fine. Before your application starts, there can be a heavy synchronous process that runs. It will read this file and package definition most probably parses your proto file. What does parsing mean? I mean, it understands dot person is a message, and add service book is a service, add service book dot add person is an RPC, so on and so forth. So it parses your proto file, and then we finally do a gRPC, which comes from the official library, dot load package definition. With this package definition, basically we get the proto file and we put it inside a gRPC function by calling grpc.load package definition. What does this do? Probably just loads the proto file. Still we haven't implemented any of our gRPC services. Still we haven't started a server yet. We haven't done an app.listen like we used to do in Express. Ignore this in-memory object. We are not using a database yet, which is why I just put everything in a variable. Eventually you should join a database, store the users over there. For now, we just have you can have an empty array or, a more complex array, doesn't matter. And lastly, this is the implementation, the add person function. But notice the arguments that it gets isn't, as simple as a person object. What was the service over here? It said that the add person function gets a person as an argument. But the arguments that you get in grpc.js include two things: a call, which means all the details of the function call, and a call back, which is something you call with the response. Basically, this call object is similar to the rec object in Express, where we used to do a rec.body.id. Here we do a call.request.name and call.request.age to get the inputs from the user. And this callback object that you get, the second object, is similar to response. You can actually, if you feel more comfortable, you can make this rec and make this res. That is fine as well. But we're going to name it call and callback because that's just convention. This has all your input details, which for the add person function, what were the input details? You get a person object as an input, which has a name and an age. So you can do a call.request.name to get the name, call.request.age to get the age, and just, maybe store it in this in-memory object for now. You should ideally store it in a database, do a bunch of other checks. Yes, but you get the idea. For now, we're storing it in a in-memory object. And callback, as I said, is similar to doing a rest.json. Okay, hey, it takes two arguments. First argument is an error. If there was any error, then you actually throw an error here, or pass an error object. In our case, there is no error, which is why we pass null as the first argument, and the final person that was created, this in-memory object, as the second argument. Notice you did not have to write any PBF compression logic, any PBF decompression logic. It was automatically done by the gRPC library. This is why gRPC is, popular. Okay, you get the benefits of protobufs. Under the hood, when I call this, the data reaches back to the other side using protobufs only. But I did not have to write any, PBF.js dot encode logic. It automatically under the hood does it. What does it? This library, gRPC.js library probably does it. Not probably, that's the library that does do it. Lastly, we create a server. Think of this as, const app equal to express to actually create the gRPC server. Server.add service. Think of this as, app.use. Any request that's coming to /person should go to, some route handler. Server.add service. You would have multiple services, right? This proto file, right now we had a single service, might have a new, to-do service in the future. So as you have more and more services, you can register them one by one. And if you remember from Express, we were doing things like these from time to time. /API/v1/user, go to the user handler. And then any request that's coming to /API/v1/to-dos, then go to the to-dos handler. So just a better way to structure all of your services separately. We have a single one right now. So we do a server.add service. Person proto, where does this come from? Here. Person proto, where basically the object that we got when you did a gRPC.load pack definition. Dot add book service. Then I had to add some TypeScript logic here. If you ignore it, it breaks. We'll get to how you fix TypeScript in the next one. But that is why I had to add this as service client controller. How did I reach this? I went to the definition and saw what the error was and then figured out amongst the many things that you can pass as an argument, only this will work or this will make TypeScript happy. And so I did a type assertion here. We will get rid of this in the next slide. But yeah, you can also TS ignore it if you want. If you feel this is weird syntax, feel free to just do, this. That will work as well. But we'll fix the TypeScript bits in the next one. Dot service. So basically, you actually need this. Person proto dot. Where did it go? Address book service dot add person. Sorry, dot service is what you put over here as the first argument. Basically means register this service with these functions. Right now I've only put the add person function here. I can put, if I want, I can put the other function here as well, which was it called? Delete. Oh, sorry. Let me get rid of this. Get person by name. And then, add another function that handles that specific RPC call. Let's just stick to one for now, but in the next slide, we'll be adding the other one as well. So this is the final code that I had to write. Let me make this smaller so it can be read together. Let's recap the code from top to bottom. We import a bunch of things, very similar to how we import a bunch of libraries when we're using Express. We import Express. Then we bootstrapped a person proto object, which sort of has the details of your proto file, understands there is a address book service, there is a message, so on and so forth. Function add person, we define the final implementation. This is throwing some TypeScript errors. Specifically, since you've not given it any types to the arguments, we'll fix this in the next slide. We initialize the server. We add a service. We give, the add person function will be handled by this guy. And if we have more, then we'll have to give more functions here. Finally, we say start the server by doing a server.bind async, give it a port to start on, and then server.start. Very similar to how you do app.listen 3000 in Express. Do we high level understand the code? How are we doing? Let's do a poll. We still have to start this process and hit it from a gRPC client. But how are we doing right now? Not great. We will take a breather and we will look at Q&A. What is this add person? Great question. It is the second argument to the add service function. It says, here add this specific service, the add book service. These are the handlers for it. What does handlers mean? Here the final RPC functions. What is a RPC? Remote procedure call. It says this is the final procedure, the add person function. I can also copy this from here and simply paste it here. Something like this. Here add person is this function. This is the handler for the add person RPC. Whoever calls the add person function, this is the handler for it. I just defined it separately to keep the logic clean. But that is what this second argument is. This second argument is all the handlers for this service. What was the other RPC here? Get person by name. So I can actually also add this person by name. Okay, the handler for this is going to be a function called get person by name, and then define that function here. What will this function do? It will take again two inputs, call and callback. What are the inputs that come to the get person by name function? It is this get person by name request message, which means it will have a name over here. So what can I do? I can do const name equal to call dot request dot name, and then I can be like const person equal to persons dot find x dot name equal to name, and then I can return this, something like this. So that is what this second argument over here is. It is registering all of your services. Okay, add person, this is the handler for it. Get person by name, this is the handler for it. Recap of the code. Let's start from the top. Bind sync repeat. Bind sync or load sync? Bind sync. This is basically, it's bind async by the way, but basically means it's similar to server or app.listen 3000 in Express. What does this do? It actually starts to listen on the 3000 port for this on this machine, right? And any HTTP request it starts to handle. Similarly, server.bind async starts to listen on port 50051, so that whenever I try to hit this specific gRPC server, there is something running on this port on this machine where I have to send the request. So the final request that I'll be sending out will be to localhost :50051. Recap of the code. Let's start from the top. Firstly, I import two libraries, gRPC library and the protoloader library. The protoloader library is a library that lets you most probably parse an a.proto file. You give it the location of a file, which if this syntax looks weird, I don't think you need a path.join. I think this will work as well. But if it doesn't work, what does the other syntax do? Basically does a path.join __ dir name, and this basically means gets the current directory and adds a.proto to the end of it. So the final thing that you will see over here would look something like this: /users /kirath /projects / /a.proto. So that's what the path library is used for. It's to join various directories together, so that if there is a / here, it gets rid of the dot and finally gives you a nice path. Most probably you don't need it. You can just give it /a.proto and it will work. Either way, we give it the location of our proto file, and then we do a person proto, which is like, load the definition of this proto over here. What this does under the hood, I have no idea. It's similar to, just calling const app equal to express. What does this do? It creates an instance of whatever this returns, right? And then you can call a bunch of functions on it. For example, app.listen or app.get. Similarly, this person proto is an object that you use to eventually register services. KR person proto, not register services. Basically, I guess this will be the name of a service or something like that. This will probably be a string. You get the idea. We initialize a server over here and we do a server.add service person proto. Yeah, this is like code that's hard to explain but should be obvious. Let me zoom this out a bit. This is all the code that we've written. Let's try to build intuition from the top one more time. We define a function. This is our final RPC function. This is the function that will finally be called. Let's get rid of the other function. Let's make the code much simpler to understand. This is the code that we've written. Think of this as some bootstrap, some imports we've done. We initialize a gRPC server by doing a const server equal to new grpc.server, similar to const app equal to express. We do a server.bind async or app.listen like we used to in Express. This is something we've done in Express many times. This and this hopefully is straightforward. If I create an Express server, if I go to Replit right now and quickly create an Express server, how will it look? It will look something like this, right? Const express equal to require express, const app equal to express, and then app.listen 3000. This much code is enough to start an HTTP server that is listening on port 3000. I haven't written any implementation logic. I haven't written any routes right now, but I've started an HTTP server that of course handles nothing. There is no handler for any incoming request right now. But if I go here, this is similar. If I remove all of this logic, I initialize a gRPC server and then I do a server.bind async this. I simply start a gRPC server that is running on a certain port and listening for incoming requests. I have not described any of my services. How do you describe a service here or describe an endpoint here? You do something like this. Here, if there's a GET request, then you do whatever you want. res.json, whatever message you want to return. And similarly, if you want to describe a service over here, you say server.add service, the type of the service, the name of the service, whatever this returns. I would assume this returns a string, but I could be wrong. And then the actual implementation. Here the add person key implementation exists over here. I could also do this, right? app.get slash, comma, add person. And then I would have a function called add person, which takes two things as an input, rec and res, and then does whatever it wants to. It finally returns a res.json, whatever. So that's how I would write a get handler on slash that routes the request to this function. And similarly, what have I done here? I've said add a service. In case there's an incoming request on the add person RPC, forward it to this function. And this function right now has some logic, but it has in-memory logic to push to a person's array and then, returns back to the end user. Okay, hey, there you go. This is the person that was just created. Similar to how here I do res.json. So do we understand it now? Hopefully with, Express on the side. Let's see. If not, we'll go over it again. That's fine. Because, this is pretty much it. It's just adding some TypeScript after this and then, some more code. Alrighty. We do understand it. Cool. Great. So given we have this, question is, how do you call it? How do I send a request and make sure things work? And the answer is, number one, you start the server. How do you do that in a TypeScript project? tsc-b to compile your code and node dist/index.js to start your code. It says a.pay.pro doesn't exist. You'll have to copy the a.proto file over to the dist folder, or you can do a /a.proto here. Either works. But it will not find the proto file in dist/proto. So you have to give it the right location. Let's try that one more time. Still an error. Cannot find a.proto. Oh, it's in the source folder. Okay. There we go. The server has started. How can I send it a request? gRPC is a popular protocol. Just like HTTP is a popular protocol, so is gRPC. Postman, whenever you go to Postman and click on File, New, it lets you create not just an HTTP request, not just a WebSocket request, but even a gRPC request. So you can go to File, select New, and click on gRPC here. And then you can start to, send a gRPC request. Give it a URL, which in my case is grpc:// I think that's right, but let's see. Localhost : 50051. Select a method. How do you put a method here? What is the easiest way? Should I put add person, or can I do something else? Thankfully, we have the .proto file. If you remember, I said initially when I opened Accelerator, okay, the proto file say you can not just generate some basic code to start a gRPC Node.js backend. You can also generate some code to do client side stuff. You can give this proto file to the client. Then the client will understand, Achha, these are the methods I need to call. And Postman is just another client, very similar to Rust. You can send a request from Rust. You can also send a request from Postman. So you can import your proto file, import a proto file from, your file system, and once you do, you can pretty much, it'll give you a bunch of methods that your backend supports. My proto had this delete user as well, which is why you see it. But let's say the add person is the method that we want to call. So you can select the method automatically. You could also just write this, but that's the whole benefit of using a proto file. Okay, you get automatically generated clients. It could automatically tell, okay, yeah, these are the 3 functions. Which one do you want to call? And I selected add person. Finally, you can write a message which will be, whatever. This is my name, and then this is my age, and invoke a function. As you can see, it doesn't say send request. It says invoke, because you're invoking a function somewhere else. So click on it. It returns me back my, name and age, which most probably means the code is working as expected, because, this is what the code looks like. It probably pushed this to the person's array. And then because callback was called with null and person, this person is what I got here on the front end. So most probably it works. You can also just implement the other service, the get user service, to actually confirm if it is working, and just call get user and send your name. And if you get back the right response here, it means your thing is working. Most probably it is. If you didn't understand this is just error first callbacks. A lot of times very common in Golang. Okay, when you're calling a callback, the first argument is an error, and if it is null, it means there is no error, and the second argument is the actual thing that you want to return. That's why you have to write it this way. It's just a common pattern. It's called error first callbacks that gRPC sort of uses. All right, do we understand this? How can we create a server, and how can we sort of use Postman to send a request to it? Of course, eventually you won't be sending requests via Postman. You'll be sending them via a React application or whatever. But are we good to go? Can we proceed from here? Something is up with the polls. Launch. Yeah, I can't. Oh, there you go. The last thing after this is just cleaning up the code and adding some TypeScript types. But yeah, seems like something is up with polls. Yep, Zoom is being a little dilly-dally. Let me try that one more time. If not, we'll just proceed without the poll. We just have to understand one small thing, and then of course we'll open it for Q&A. Alrighty, there we go. Okay, we're good to go. Sort of 85% is decent. Let's finish the last slide, and then of course we'll open it up for questions. The last slide here, basically this code is slightly ugly, and by ugly I mean I'm using ts ignore in a few places. That's not great. If you're there's no point of using TypeScript if you're using ts ignore everywhere. So how do you get better types in this specific server is what the next section is going to be. Thankfully, the library that we were using, Protoloader, had a section at the end. So I was also Googling this. I've used Proto, but not in a Node.js project or like gRPC in a Golang project. So I was googling this, okay, how do you get better types? When I wrote the code initially, I could see that types were really bad. And, thankfully, at the bottom of this library, the proto loader library that we're using, this library right here, there was a section that said, okay, if you need TypeScript files generated, you can use the proto loader gen types. Now, I don't know if this is the right or like the only way. There are probably other ways to generate types, but this is one. This library gives you a script called proto loader gen types that lets you generate types. These are all the options. The question is, where is this proto loader gen types CLI here? CLI stands for command line interface. These guys say it comes baked in with this library. So basically, when you did an npm install of at gRPC / proto loader, which is, this library right here, along with all the main code it brought, it also brought one more file called, so if I do a node node modules / at gRPC / protoloader / build / bin / there is a script over here called protoloader gen types. It's a very ugly way to do that. They should probably give a CLI, but whatever. They give you this file, which is effectively a JavaScript file that lets you generate the types of a proto file. Given a proto file, it gives you a very nice types that you can use in this file. So you can get away with all the TS ignores that we're using. So what do you do next? They give you a script that you can run, which is the script right here. I think I've pasted the same here as well. So you can just copy this code right here, give it your a.proto as an input, and give it an out directory. Okay, generate all the TypeScript files, generate all the types in the generated folder, or you can rename this to whatever you want. If you paste this script over here, it says no such file exists because a.proto exists in ./source for me. Let's try that one more time. Our ./source / a.proto. And there you go. After I ran this command, you should run it on your machine as well if you're following along. Again, it's a script present in ./node module / at gRPC / whatever. When you run this command and give it this as an input and give it the out directory as generated, it generates a bunch of types for you. As you can see, the best thing it generated is this a.ts file. Why is there a TypeScript error here? I don't know. There are red squigglies here. I don't know why. We'll see why that. We'll see if that's actually an issue or just VS Code being VS Code. But it generated a bunch of code automatically for you. This is similar to auto-generated clients. Only we have not generated a client. We have generated some types on our backend that we can directly use in index.ts. In index.ts right now, if you remember, I had a bunch of ugly code over here that I finally TS ignored. If you remember, I did something like this, as unknown or as some server, some type over here. If you automatically generate types, if you create this generated folder, then amongst the many things it returns you this global proto gRPC type that you can just set over here, I think. Of course, have to import it. Oh, that makes sense. I need to just move the generated folder to source. So this generated folder I have outside the source directory, which is why there are a bunch of type errors. So I just need to move it here, and then things should be fine. There we go. And yeah, as you can see, it's already throwing an error and telling me, okay, get person by name request person. Maybe this is not the right place. Let's see. Where do you add the type? Oh, you have to infer the type. That makes sense. Yeah, they're still pretty ugly, but this is what they recommend. You can't put the type here. You have to infer the type on the right. Basically something like this. There we go. And now you can get rid of all the TS ignores. If you don't understand this I sort of, not Googled my way through, went through the library, where it go? This library, and realized that this is what they are doing. They created const example server equal to this is the type, and whenever they're creating proto, they do this thing as unknown as proto gRPC type. So basically followed the steps that they mentioned over here. What are the steps they mentioned? They said first generate all of your types, by running this command. Give your proto file as an input, give an output directory where you want to output all of your types. And then they said, whenever you are creating your, proto variable by doing a grpc.load package definition, infer or like give an explicit type over there of proto grpc type. Harkirat, why as unknown as proto grpc type? Whenever you cannot do this is when you do this. If you directly do it without as unknown, it'll say the type of this thing is incorrect, it cannot be converted to this. So if you ever want to force types, you will see this in code bases from time to time. You first convert it to unknown and then convert it to whatever type you want. So yeah, now this object has a specific type. If I hover over this, you will see it has the proto grpc type, which is defined in the auto generated client. And that pretty much, if I use this anywhere now, if I do a proto.addBookService.service, this actually exists. And I don't have to put a TS ignore here, just I had to before. And if I hover over this now, or if I move this function over here, basically, then this will also automatically get types. If I hover over call, you will see it has, why does it have an implicit any type? Server. This should have been able to infer type. Something small I'm saying, let's see. Oh, you have to, you have to create handlers separately. Yeah, let me quickly do it and then explain. What should be the type? Address book service handlers. There you go. And this needs to have add person and then get person. All right. There we go. So the other type that it gives you is this address book service handlers, which again, how did I find this? I went over here and realized that when he has created the handlers of its final RPC, that it got the type from somewhere. I got the type from the same place, but I feel I've said a few things very fast and everything went over your head. So I will take a pause before I complete the implementation. Let me start from the top on this specific slide. What was the problem in our original approach? The problem in our original approach was that I had a bunch of NEs or a bunch of TS ignores. Basically, this add person call had no type. I did not know what the type of call is. It wasn't auto-generated. Same for callback. So, I could either make it any or I could just TS ignore it. Similarly, here also I had to infer the type of person proto.addressBookService as something else because there was some TypeScript error. This shouldn't be an error, but for whatever reason there was an error over here. So I had to do a bunch of type assertions. I had to put a bunch of TS ignores to get better types. The one thing that these guys recommend is, we will give you all the types given your proto file. Given your input proto file, I will give you all of your types, which means, interfaces, types, things like these. I will automatically generate them for you as long as you give me the input proto file. So this was our input proto file. It has 2 services now. I just saved it. And this was automatically generated from it. This has 3 because I forgot to save, but this would be the final file that would appear. And this type that is automatically generated, I can just use in index.ts when I'm creating my handlers. And what is the benefit of that? Okay, now I don't have to, it automatically tells me add person is something. If I give it the 2 arguments, call and callback. If I do a call dot, it automatically tells me a call dot metadata is something or call dot request is something. If I do a dot, it gives me automatic types. Age is something here, name is something here. That was not the case in the last slide. If I go to the last slide, here I did not know what the type of call is. I did a TS ignore. It was any. So I did not know call.request is something, or TypeScript wasn't able to tell me or check if I was doing something wrong. If I wrote a dot name 2 over here, TypeScript would not complain. But now, thankfully, since I have these types, I can, do a call.request.age. But yeah, it's fine even if you don't understand this. I guess it's like we've done this a little too much. How was this? I think this was pretty bad. But let's take questions after this. And if needed, let me just copy the whole implementation and show you that it does run the code is still the same. Oh god, the code is still the same. Let me just copy the implementation really quickly. So the function call should still be the same, but only we have better types now. Basically, I don't have any TS ignores anymore. So this is a more strict code to write. But even if you write the other one, I guess it's mostly fine. And here, if you look at it, in the get person by name, I also return an error in case the person isn't found. So I try to find the person given a name. In case they're found, I return the person. In case they are not found, I give the first argument, which has some details. Okay, the user is not found. This is the status code for it. And these are the details. This also I figured out through the types. I went in there, went to the definition of the callback function, and slowly reached. It returns the status, and then understood that this is what I have to put, and then null as the other things. Basically, if someone calls this function with a username that doesn't exist, we return an error to them rather than returning them the name. Cool. This will work when you start it. But okay, let's take a pause here. Let's open chat and let's answer some questions. I feel there were a lot of questions, at least in this section or generally. Let me just look at Q&A first, and then I'll open chat. If you understood everything, then feel free to call it classes done. All right, let's see. Why a.proto RPC server is add person and index.ts server add server. Add person name and value. I'm curious about the camel case. I think it works. I get your question. I think even over here, if I write add person rather than having a capital A, the handler is able to understand, and it's not camel case. It's not case sensitive basically. Can you share a repo where gRPC, like an open source repo? I have a closed source repo where it was implemented, but let's see, gRPC, like you probably need a better company or slash a real world example, which I don't have right now. And gRPC is usually not used in Node.js. Whenever you're using proto files in gRPC, they're mostly used either in Golang or maybe in Java, but Golang is the most popular language in case you're ever using gRPC. I can tell you one thing, gRPC is used here. Have you heard of Cosmos? So if you really want a repo, and if you want to go fancy, this will have a bunch of proto files. If you ever create, so Cosmos is a blockchain that lets you create your own blockchain. I repeat, if you look at this thing right here, Cosmos is a blockchain that lets you create other blockchains. It's written in Go. And here, if you ever want to create your own blockchain, all the messages over there, the format that they use is proto. So if you want to, basically this was given to me as an assignment, create your own blockchain, create your own social network blockchain thingy. So if you ever want to create one, you will have to use proto. I might just have it if I'm being honest. Let's see. What was that called? Cosmos. Social network. It's there somewhere, but there's a repo I have which was like an assignment that I had to do for a company that was on Cosmos, where I was like interviewing last year. The question is, do I have it? It's too far along. If I find it, let me just look for it right now. If I'm being honest, I will forget. Cosmos, crypto, decentralized. Yeah, I cannot find it. But yeah, try creating your own. Go to Cosmos SDK basically, and here you'll find, if you want to create your own blockchain, you have to basically define all of your schema, what data you will store in similar proto files, and have similar implementations like we did today. But all of those implementations will be in Golang. Data returned in Postman seems to be JSON, not in PBF. JSON also understands. Sorry, Postman also understands. Even if you use a client-side library, if you auto-generate a client, the library will decode the data and give you the data in your final JSON format, because that's what is human readable, right? So over here also Postman understands. Okay, this is a GraphQL client, a gRPC client. Whatever data I get back will be in PBFs. It sort of decodes it. Can you share a repo where gRPC? Okay, answer that. I'm not able to understand how gRPC is better than JSON. It's compressed, right? You're sending much less data over the wire. Oh, better than JSON RPC, same. And is able, then also used by all Ethereum, Solana, Sui. What is the logic behind it? Is readability? So just because you are sending the data to the blockchain in JSON RPC doesn't mean that's how the data is being stored. The data that's stored on the blockchain is heavily compressed. Also, JSON, it's so easy to go in Postman. gRPC becomes highly, a niche library for a blockchain to support. Most blockchains should support HTTP. I'm surprised they even support JSON RPC, or they expect. I'm sure there's a reason for it. Most probably one blockchain did it and then every blockchain followed. But yeah, it is what they do, and they do not follow. Should they follow? Probably. Probably makes sense to compress data, considering so many people are sending so many transactions to the blockchain all the time. But yeah, they don't. Why null in callbacks? As I said, this is error first callback, which means the callback here expects KR just how you used to do rest.json, the final data, or if there was an error, if you remember, you used to do rest.status 411.json and send message there is an error, something like this. So this is how you would tell the other side, the client, that there is an error. In case of gRPC, you give the first argument as null if there is no error. This is a error first callback. Null means there is no error. Then you give the final object here. But if there is an error, then the first argument here is the error object, and the second argument here is null, because doesn't matter what the second argument is. There is an error, so that's what will be propagated to the end user. So that's what that's why I need nulls over here. Yeah. In the first place, it means there is no error. In the second place, it means there is an error, which means we don't really worry about the data. I read that we can host RPC nodes for Solana. If it is that hosting RPC node being a middleman for different users, passing the request to the minister, getting the response from the Solana server and sending back to the HTTP response, or please explain in this context. Also, gRPC equal to protobuf compression plus RPC. You could say that gRPC equal to protobuf compression plus RPC. gRPC equal to JSON RPC minus the JSON plus the protobufs. And to answer your first question, yes, hosting, there are two types of RPC nodes that you can host on Solana, for example. Forgot the name, basically lightweight and not lightweight, voting nodes and not voting nodes. So basically, if you remember in the beginning, I showed you this, right? I was hitting a specific RPC URL that Alchemy is hosting. A lot of people need to send these requests. Here, what is happening on the blockchain? Tell me, give me the balance of a specific wallet address, so on and so forth. So you can run lightweight RPCs. These don't participate in consensus. By consensus, I mean they don't really, if you understand what consensus is, they don't really verify all the transactions, create a block and submit it on the blockchain. They simply are for reading data. There are many such RPCs. Most probably that's what Alchemy does as well. They don't have a voting node. So this is much cheaper to do. To create a lightweight node, you just have to pay for compute and bandwidth. But the other thing is, what was your question again? Is that hosting RPC node is being a middleman? It is a middleman. So that's what Alchemy does, right? They did the heavy lifting, heavy work of bringing up an RPC, and then they charge people, if whoever wants to use their RPC and not host their own. So yes, it is becoming a middleman. It is transferring your transactions, taking transactions from you, and talking to the blockchain. How handle is replacing previous functions? Oh, handler is basically you mean. So yeah, previously I had an object here. Here is an object where there is a add service or whatever, add person, which is a function that was defined above. Function add person. And then, other functions. This is how I added before. Now I said, rather than defining the object here, let me take this, creates a new variable called handlers. And that handlers variable is an object. And then, define everything in there. So rather than having this object directly over here, I just moved it to a separate function. Why? Separate variable. Why? Because I can just give this a type. And if I give this specific type, it'll give me all the type assertions. Okay, call.request.name is something. Why is it not giving me right now? Oh, because it needs to be capital A. There you go. It just gives me call.request.name is of type string. It infers all of these types for me, which is why I created a separate handlers method over here. You talked about backend role opening. When? I have Solid Express. What are the expectations offering? There was two people, although two people have already been chosen. That person also said they'll start next month. So nothing really happened there. But I think 2 people are already chosen for that. In Postman, you need to use gRPC // That is correct. Where is data stored? Right now it's stored in a in-memory variable. Persons, this array right here. But of course you can replace this with a database call. The way we can call this server from client is different as WebSocket. Yes, you cannot do a fetch. In fact, you can't. Your browsers don't even support the gRPC protocol. If you want to call a gRPC server from the browser, you don't do that usually. gRPC is only for backends to communicate. Backends can have gRPC clients and gRPC servers. Browsers usually do not talk gRPC, and there are weird ways to make it work, but usually it's for microservice communication. And it's not, you cannot use a fetch over there or a WebSocket over there. Should we just someone asked related to Web3? Long story short, full stack is the core skill, right? Everything else is how much niche knowledge do you have on Web3. If you have it, little bit. Do you have it enough to be able to contribute to a part? For example, in Backpack, I did not know blockchains very well. I did know a lot of smart contract logic. I did not need it. So it's about how can you get enough knowledge to be a full stack engineer in one of these companies. That's how you think about it. Okay, one big question where repo link. All right, just answering questions first, and then I'll look at prepos and other things. For the backend role, we need to be comfortable with. For that specific role, it was just, I think they're pure Node.js, so you don't have to worry about Rust or anything else. Where exactly is gRPC used in the industry, and how much value does it add to someone's resume? Oh, if you are applying to any Cosmos company, then you need gRPC knowledge. You need Go knowledge as well, but you definitely need gRPC knowledge. Other than that, a lot of games use it. Basically, GatherTown used it. In Gather, all the messages that that were exchanged between clients, they did not use gRPC. They used protobufs. Protobufs are more commonly used in places, in companies. gRPC not so much. But yeah, you'll find some ecosystems where it's heavily ingrained. For example, as I said, Cosmos ecosystems. Like find the biggest company in Cosmos, or even small companies, and I'm sure there aren't enough people who know Golang and gRPC. So easy way to get in. Yeah, that's. If you're thinking about what's the best outcome for me to follow if I know this specific stack, the answer is some Cosmos company. At least that's what I know. Solidity roadmap for what the hell? Someone posted that DB credentials. Why is that? Solidity roadmap. Look at all the contracts in OpenZeppelin and understand them. All the standard contracts that have been written. Try to go through Uniswap v1, v2, v3. Yeah, that's the best thing. If you know them, then you will find your place somewhere. Although smart contracts are not something you write day to day. So I will keep repeating this. Full stack knowledge plus enough knowledge to understand the companies. The best thing you can do. All right, week 23 RPC. Aditi here. Explain how to handle timeouts in an RPC system. You can do something like this, right? So if you basically by timeouts, I guess you mean. On the client, you can be like, if the function call hasn't succeeded in 5 seconds, I will forget about it. On the server, you can put a timeout over here. Okay, if certain thing is taking more than 5 seconds, or if the database call is taking more than 5 seconds, then you can simply return an error. Okay, sorry, it took more than 5 seconds over here. So you can add ad hoc logic. I don't know if probably on a gRPC client you can specify some sort of a timeout. And it will, automatically error out in case it takes more than 5 seconds or whatever the timeout is. So I would assume this already exists on the client. If it doesn't exist, then you can just write that logic. What is protocol buffer? Well, you should go back to slide number 1. Protobufs or protocol buffers are a protocol that lets you compress data a lot. Basically, 1 second. Basically, to transfer data between multiple services, initially XML was the most popular format. Then JSON came. Today, if you look at it, most people use JSON. Don't even worry about it. Use JSON and call HTTP servers, get back some response, so on and so forth. But JSON is very expensive. Unfortunately, the world has moved to a place where everyone uses JSON left, right, and center. But if everyone moved to a more compressed format, it would be nice. The question is, can you create your own compressed format? Can you write your own logic to, before you're sending the data, compress it, before you're getting it on the client, decompress it? Yes. protobufs are more standard. Right? They said, okay, this is the problem we solve. We know JSON is bad. We are a better JSON. If you want to transfer data, transfer using us. Purpose of gRPC in microservice architecture. Slide 1 had a bunch of downsides. All of those downsides go away if you use gRPC. What were the downsides? No types. We use JSON and not a slightly smaller format. The developer has to know what Axios is and not language agnostic. All of these problems go away if you use gRPC. Can you give an example where we would use HTTP instead of gRPC? If you want your browser to talk to a server, you have to use HTTP. Browsers don't understand gRPC. It's not a browser protocol. Browsers haven't implemented gRPC yet, which is why, if you ever have a full stack application, then you have to use HTTP. If backends are talking, then you can use gRPC. Why not use gRPC? Why gRPC uses HTTP 2 and not? It's a conscious choice. Also, gRPC as a protocol is not just for one-way communication, but also for two-way communication. And you can't do that in HTTP 1.1. That's probably the one of many reasons they use HTTP 2.0. Can I define a gRPC call with a null request or no response? Yeah, you don't have to have any inputs. You can, I guess your question is, can a service have null over here? And the answer is probably yes. You can probably do this only. Have an empty request, or I'm sure there's a different way to achieve the same thing which you're asking, which is no inputs / doesn't return anything. I'm sure there's a way to do it. The syntax might not be exactly this, but yeah, I'm sure there's a way to not have any response and not have any incoming data. In the OSI model, for example, in the OSI model, what is where? For example, protobuf is at layer 4. I have no idea. Protobuf is probably nowhere. gRPC is probably at the application level. I could be wrong, but most probably gRPC is at the application level. Is protobuf somewhere? Protobuf is just data format, right? So yeah, I don't know if it even lies on any layer in the OSI model. Is gRPC? I don't know if it's faster than HTTP, faster than REST with HTTP 2. I would assume it is because it's sending data in a more compressed fashion, and hence it should technically be faster. Can we implement REST plus protobuf? Yes, if you have protobufs or REST plus, yes, you can. I'm sure there's some library. Express with PBF. I'm sure there's a library that you can of course write it yourself, like compress data before you're sending. But I'm sure there's some library that lets you do npm proto, just like plug in and directly converts your data, incoming data, outgoing data to protobufs with Express. Yeah, or there you go. You just look at this library and this code and see what it does. Yeah, alrighty. Now let me open chat. I think Q&A is filled up. Alrighty. Do we have to add .proto in all microservices? Yes. Whoever wants to talk to a microservice, whoever wants to define the microservice needs to have the .proto file present, so they can auto-generate clients and auto-generate the server logic. Can we auto-generate proto file like OpenAPI spec file? No, unfortunately not. You're thinking of it, they're like opposite things. If you have a code, you generate an OpenAPI spec file for it. But if you have a proto file, is when you write. Why does it not stop you? There you go. If you have a proto file, is when you write the Node.js logic for it. So you cannot write any Node.js logic unless you have the proto file. So it cannot be auto-generated. Unfortunately, it needs to be written by hand. I've implemented the blockchain hello world post. Yeah, yes, exactly. That's almost exactly what I wrote. Let's see what you've written. But yeah, I had a very similar create. So you have a proto file somewhere here, I'm assuming. Where is the proto? Oh, there you go. Proto, buyout. There you go. Genesis.proto, query.transaction.proto. So yeah, basically someone also wrote this. Probably is a Cosmos application, right? So yeah, that's probably that's where I also used proto files heavily. I've used them at a different company as well, but not as heavily as when creating a Cosmos blockchain of my own. Stuck here for 2 days. Let's see. Hi, in order to get a remote job, I want to contribute. Need to contribute. Where do I need to contribute? I want to contribute. Where do I need to contribute? You can contribute to one of many open source repos. Today, almost every company is being disrupted by, just look at YC, you'll find some open source for X. For example, recently I saw someone created an open source Loom. Loom in itself is, I think, got acquired for $1 billion. So there's a high probability they raise. If they raise, then, they need engineers. If you're the top contributor, they will hire. So you'll have to find these projects yourself. I can tell, but then everyone flocks to those projects. There are some standard ones that everyone knows. Documenso is one. Dub.sh, yeah, Dub.sh is one. There are like a bunch of others. But find one your own. That's half the. Find an open source project that's either about to be funded or is already funded, and then contribute heavily there. After how fast should us move to Web3 videos? Just okay, answered that one. I think. Like fully function, or should we start doing Web3, learn Rust, or first? Yeah, the easier way is just the video, for example, doesn't have any Rust. You don't write contracts on most days in a company, in a Web3 company. You write standard full stack stuff. You talk to the blockchain from time to time. Have to be a little more secure when debiting and creating money. But other than that, is a lot of full stack code that you write. So basically, yes, the video is pretty relevant. In the sense that, it doesn't touch a lot of Rust concepts, rather focuses a lot on, the blockchain, or, full stack plus blockchain kind of stuff, which is what you mostly do, which is enough to get in. I got internship, Golang. Can you please suggest a few resources? Golang layer. So wait, what's that called? I learned from Go from example, I think, but again, to most languages you go from example. Most languages you learn on the go. Go. What is it called? Golang with examples. Go by example. There you go. This is a decent resource. I've created a mini wallet using RPC nodes and Getblock today. Question is what to do next. Can you show what you've built? Does it sign transactions? Is it an extension? Can it be used by dApps? Have you connected it to common wallet adapters? There are like a lot of things to do in a wallet. Basically, have you done everything? Are you parsing the transaction yourself? Are you using someone else to parse it? But yeah, either way, if you've built a wallet, I guess your question is what can I build next? Wallet is probably the last thing that you build. Try creating a DEX or a SEX. Maybe create some. Maybe get good understand L2s. So one thing I'm learning these days is a lot of ZK stuff. So maybe try going there, understand about L2s, rollups, and how do you create your own blockchain, I guess, is the next thing after you create a wallet. Or maybe try to make your wallet multi-chain. I guess that's a decent thing you can do. So the most general use case of gRPC is to be a mediator between different services. Yes. In a company, if so, how does it connect functions from different services together? How does it connect functions from different services together? That's exactly what it does, right? If you remember, I said at the center there is a protofile, and doesn't matter, your implementation of the protofile can be in any language of your choice, Node, Go, whatever you want, and any other client, be it a Rust client or a Postman client or a Golang client, can not directly call function, but do an RPC, can call a function like this, for example, sum, which of course under the hood will send a request, but all of that logic is hidden from you. So that's exactly what it does. Your question was what? If so, how does it connect? It doesn't connect anything. It just automatically generates a client, which under the hood sends a gRPC call here and gets the response, parses the response, and just returns the thing to you. Alrighty, let's do one more, guys. I think I missed a few. And then we'll call it. Alrighty. Where have you deployed the CMS database? I've used neon.tech. And we don't have object storage. If we do, it's in S3. Basically calling functions on server which you don't want exposed to the world, kind of like ChatGPT accessing GPT-3 and GPT-4. Can you suggest some repos I've contributed to? I've seen Pyre Media Soup. Weren't more many issues. You mean WebRTC? I didn't understand the first question. Sorry, first statement. You want WebRTC repos LiveKit. Have you tried LiveKit? I'm sure there is a lot of activity there. Yeah, I would do LiveKit for a bunch of reasons. Yeah, it's in Golang though. Stuck here from 2 days. Let's see. Can you just a little demo on how to find a YC company on YC? It's been a while that I've done it, but what's it called? So there's work at a startup. I don't know if this works, but work at a startup is the official YC directory. So you can try this, or YC company summer 2024. You'll find all the companies from the specific batch here. Yeah, for example, what all companies got selected in summer 2024, and then go through them, see which one of these are open source. Why is it only showing one? I guess some 24 is about to start maybe. But yeah, that's how you go through all of them. This also doesn't cover all the companies. I think maybe it does. Just find the one that you need here and go from there. Find the founders, LinkedIn, Twitter, message him. Yeah, or her, I guess. What are the steps to follow for a mid to senior developer? I have 5 years of experience in Node.js. Seems like there is a knowledge gap where whatever is happening in the current market, whatever I'm doing right now, it's hard to contribute to open source. Yeah, so your answer is in your question, which is, you've probably done the same thing again and again in JavaScript, but the world has moved to TypeScript, gRPC, gRPC, God knows what. So you need to upskill, and the best way to do it is get uncomfortable. And you're saying I'm not able to contribute to a project. That's exactly what you have to do. And do the hard bits of understanding what they've done. One easy thing you can do is first build a lot of your own projects or contribute to smaller ones. But yeah, in the end, this is something no one can teach. You will only build the muscle. How can someone else build muscles for you? They can't, right? You have to pick up weights yourself. So the same logic applies here. You can be handheld in one issue or two, but eventually, unless you're doing the hard things yourself, it'll be very hard to do what you want to do, which is like whatever, get a job, or yeah. Alrighty. Sorry, I opened this a few times. Where are you stuck for 2 days, Akash? Please add TRPC video from cohort 1. Just ping this to Rookie, you have his number, right? Let him know. Week 16 offline lecture about cookies. You said cookies are more secured, so I implemented about one stack cookies. Now I'm facing the following issues. First, the client and server are on the same domain, so cookies will work on Vercel. Frontend is here, backend is here. Problem: browser is not able to set cookies. Okay, blocked this domain attribute was invalid in regards to the current host URL. Can you show your cookie configuration? You probably just need to give the domain. Cookie has like a few options. There you go. Options equal to secure. Are you sure this comes out to production? Basically, are you sure this is coming down to true? Same side, none looks fine. It's working when I set the cookie from the backend with this thing. So where do you face the issue? Where does it not work? But facing issues, I try to improve security, tackle CSRF attacks by adding, okay, what do you add from here to here? Secure domain. When you add the domain is when it stops to work. Are you sure the domain is right? Should it work with the domain? Yes, it should. Can you try hard coding the domain over here? This will probably return you a very very big set cookie header. Can you log that as well, or like show that, put that in the doc over here? Let's see what else. Can we auto generate proto files? Like, okay, you cannot auto generate proto files. Because when you're in the OpenAPI spec, you first write your code and then you generate the OpenAPI spec file, so you can auto generate it. When you're writing gRPC code, you first write your proto file and only then can you write any Node.js code. So yeah, you cannot do that. It cannot be auto generated. You have to write it by hand. All right. So JSON RPC is used for RPC without compressing the data. Yes. How the server actions is similar to RPC, because you're calling a function which under the hood sends a HTTP call. Right? If you remember the server actions class, even though you're calling a function on the client, under the hood it sends an HTTP call to a server, runs the function there, gets back a response. So it's very similar to an RPC, right? You're doing a remote procedure call. You're calling a function, but under the hood, it's sending out a backend request. And why do cal.com is a turbo repo? It also uses TRPC. Well, that only they know, right? Why they chose turbo repo slash chose to use TRPC. I don't think they use TRPC throughout their code base. I think use it for some services. How do you fix TypeScript errors just by going through the declaration files? I usually don't understand it. It comes with experience. For example, today, this specific type, status and everything. How did I reach there? I was trying, it did not happen. But let's say callback. What is the type of callback? It was this grpc.unary sender. I went here, then I went to unary. No, what was it? Callback, which is the second argument. This thing, the second argument here was send unary data. Then I went over here. Then I realized this has two arguments. Error looks something like this, server error response. So I went over here, which had two types. The first one was this, which was a partial of this, which is how I reached so there is a status code I need to send. Then I hovered over this and realized so these are the status codes that the server supports. Then I realized okay, so go back here. The callback, when you're sending an error, there is a code that you need to send, which can come from this status object that I just showed over here. And then the details can be whatever details you want. So that's how it comes with experience. Nothing else. Yeah, you write it out of TypeScript code, it becomes very easy. Can we do all the stuff with gRPC as compared to regular Express server, which supports middleware? Or you can do everything, authentication, yeah, all that jazz. External libraries, ORM, yeah, you can do. Is there any limitation of gRPC known to you? No. Off topic. Your view on Angular Bazaar? No idea. Completely disconnected from Angular for years now. Web3 video is live. Nice. Off topic. How? I hope I am not annoying with. Fine. All good. Alrighty. Cool guys. We're supposed to do a live. Let's see if that happens. If it happens, it'll probably happen around 10:30. I need to go for dinner. And then in the live, I'll most probably be reviewing some pull requests. We'll let you know if that happens. Like probably post on Discord. We'll just be reviewing all the pull requests from all the repositories. With that, good class. Let's end it here, guys. I will see you guys tomorrow. Have a good night. In case you're sleeping, in case not, I will see you guys in the live stream. All right. Oh my God, a few more things. Seeing there's an important question. All right, let's call it, guys. Bye bye.